The next speaker is going to be Professor Brian Armstrong, who's going to do our keynote address. Prof. Armstrong has been known in the industry for a long time, I think 30 years of being in senior management positions in telecommunications and information technology. He has consulted broadly on these topics in South Africa and also internationally. Brian, if I may say, you know, there's some guys I met when we arrived that didn't really come for everything we have to say afterwards, but they heard that you were a keynote speaker, so they came for Brian this morning. So we are really looking forward to hear your keynote this morning. Welcome and thank you.
Good morning, everybody. I need a clicker, but while they find that, so I'm really delighted to be here. This is actually the first public talk I've done since the end of COVID. So I'm really happy to be here in person. It makes a great change. I'm going to be talking to you about the opportunity for technology and how technology changes the world. Sorry, if I could ask the guys in the control room to give me my presentation on the comfort monitor. Now, when you have a topic like that, it's very easy to think, I'm going to talk about the future. I am not a futurist. Once upon a time, I was an engineer. Then I became a manager. And now I am at the Wits Business School, and I do research and lecturing and teaching in business science. So I would call myself a business scientist. So what we try to do is not make sort of lavish predictions about the future. What we try to do in business science is understand how the world has worked, how it does work, and on the models that we develop in that, the predictive power of those models allows us to think about the now and the future and how we respond. So that's really the ground I want to go through today. I just want to check how many engineers in the room? Quite a lot of you, that's good. Accountants? Okay, so it's just engineers, so I can cover a lot of ground because you guys are good at absorbing information. Now, I mentioned this is the first public talk I've done since the end of COVID. Shortly before COVID, I did another one, and I was desperately looking for a joke on the fourth industrial revolution or technological disruption, so I Googled all sorts of different phrases, and I could find nothing. Clearly, the world doesn't think technological disruption is a funny matter. But eventually, I found one, which is very relevant to today as well. And there's two reasons why this, I think, is quite relevant. The first is people say context, context really matters. And in the African continent, we do need to recognize that it's one thing to talk about technological disruption in the fourth industrial revolution in the developed world, but we do need to relate it to us. The second reason this is actually relevant is when I've in the past spoken about the fourth industrial revolution, people often, the question I get the most often probably is, Brian, you're talking about the fourth industrial revolution. We can't even get the second and third industrial revolutions right. Shouldn't we focus on the second industrial revolution before talking about the fourth? And the short answer to that question is we have to do it all at the same time. We have to do it in parallel, because if we wait to get the second industrial revolution, the world will have moved on and we'll be left behind. But the relevance applies at a business level as well. Because when I was in business, there were a lot of people saying, Brian, just focus on getting the basics right. I was in telecom for a long time. And those of you that were with me in the industry at that time know we had a lot of basics we had to get right. But that doesn't mean you can't think about building the future as well. You have to do it at the same time. And I think that confronts many organizations today. Yes, we have to get the basics right. We have to deliver the numbers. We have to deliver the business of today. But we have to create the future and build the business of tomorrow. There's another slide by way of context, just to set this up, that says, how can you talk about technological disruption when, Brian, the biggest disruption the world has seen for the last half century, COVID, has happened? And the way I respond to that is to say, well, actually, there's this metaphor that I'm sure you've all heard of the boiling frog. Let me just repeat it for those of you to unpack it. The story goes, if you take a frog and throw it into a pot of boiling water, it will jump out because the shock in the temperature difference will cause it to react and jump out, and it will be okay. But if you take a frog and you put it in a pot of cold water and bring the pot slowly to the boil, because the frog is cold-blooded, it will not notice the temperature change, it will not jump out, and it will boil to death. COVID disruption is a bit like taking our businesses and throwing them into the pot of boiling water. And our businesses all responded. We responded profoundly and dramatically. And most people were surprised at the way that business could respond to COVID. And it's been very painful, but most businesses have survived. Some have even thrived. Tech disruption is a bit like taking our businesses and putting them in the pot of cold water and bringing it slowly to the boil. Because it is a pervasive, persistent, powerful change in our environment. And if we don't respond, we are like the frog that is at risk of boiling to death, or let's say dying. Our businesses are at the risk of dying as this pot of technological change gradually boils and raises its temperature. And I'm going to make, in the next half hour, this very profound, sort of provocative statement that says tech disruption is actually more powerful and more disruptive than COVID has been. And in fact, that it is the biggest driving force of social, economic, and business change throughout human history. That's a pretty provocative, bold statement to make. So let me tell you how I'm going to unpack that. The first is, how has technology affected society and the economy? More importantly, it's one thing to know it has. How does it? How does it do this? What are the mechanisms? Then we'll relate that. There's a lot of three-letter acronyms going around today, like NEC and RAN and all this. I'm going to introduce you to a new one. It's the TEP, a techno-economic paradigm. And how does the fifth techno-economic paradigm and 5G help us think about the future? And then it's a case of saying, with that background, what is the actual opportunity for 5G in South Africa and Africa? And finally, very briefly, how we're going to respond. So without further ado, let's talk about technology, the economy, and society. And we all know the narrative of the fourth industrial revolution by now. What we don't all know is the Japanese narrative, Society 5.0. And as is often the case, Japanese cultures take a longer-term view of history, or Eastern cultures generally. And the Society 5.0 narrative starts with Society 1, the hunting society. We then learned to domesticate animals and cultivate crops, and we became the agricultural society. Then, with the invention of the Gutenberg press, which led to the dissemination of knowledge, the invention of the whole cotton mills, the Arkwright mill, the spinning jenny, steam engines, we got the industrial society, which, for those of you that know the fourth industrial revolution narrative, that corresponds to the first and then second industrial revolutions. And then we got electronics, telecommunications, the transistor, microelectronics, computers, and that gave rise to the information society, which is, of course, the third industrial revolution. And that brings us to today, where we are on the cusp of what's called the cyber-physical society, with the blurring of the boundaries between what people do and what machines and technology does, which is this fourth industrial revolution. Okay, so much for this quick lecture on the fourth industrial revolution. What's important about this? My anthropology colleagues at WITS tell me we evolved to be modern human beings about 250,000 years ago. It was about 10,000 years ago, 8,000 BC, that we learned to domesticate animals and cultivate crops. It was about 1600, 1475 precisely, the Gutenberg press, but all the inventions that flowed from that, 1600, 1700. It was really in the 1980s that microelectronics and computers diffused into the world, and that brings us to today. So the first thing that's really important to notice about this is that this period of acceleration, that these societies learned from 240,000 years to 10,000 years to 400 years to 40 years. And the important thing for that businesses need to recognize is we don't have the luxury of waiting generations to respond. It's hugely unsettling. It causes social stress and it causes organizational stress. But our ability to respond is being challenged because of this acceleration of the rate of technological change. But the other important thing about this, which I'm going to unpack a bit more, is I made the point that the transition from society 1 to 2 was due to our ability to cultivate crops and domesticate animals. From society 2 to 3, it was the Gutenberg press, the spinning jenny, Arkwright's mill, the steam engine. From society 3 to society 4, telecommunications, electronics, the transistor, microelectronics, the computer. Society 4 to society 5, artificial intelligence, Internet of Things, pervasive connectivity, and I could carry on. So the point is, it is that technology is actually the single biggest factor. It's not the only factor. It is the single biggest factor which triggers these changes in human history, these fundamental ways that humans have organized and conducted themselves and lived. We even go so far as to define stages of prehistory by the tools and the technologies that people used. From the Stone Age, where we use stone tools, then we learned to craft bronze into implements and tools, and then we learned to forge iron and craft iron into tools. So we even define the major periods of prehistory by the tools we use. But let's get back to a little bit more recent history, and there's a number of perspectives. I'm going to skip over this quite fast because I want to make sure I've got time for the substance. So we've got these various narratives, but there's others. So an American historian by the name of Lewis Mumford, he said technology, he's actually a sociologist. Technology, he says, has shaped human history fundamentally in 3 ages of human history since the year 1000, where we learned to use wood and glass and water to actually, that shaped the way we lived. And then we learned to use coal and iron and industry, and that shaped the way we lived. And then we got electricity and self-standing machinery. So that's another perspective of this. Far more recently, a scholar called Hilbert has said, actually, if you think about all these waves of change, from 1 million years ago till 1500, 1600, everything was focused on how we transform materials to do jobs that we need to do better. Then from 1600 to very recently, it was about how we transform power, to move from horsepower and manpower to water power, steam power, hydrocarbon power, electricity, nuclear power. And now it's about how we transform information. And that's the era we're in. There's economic substance to this. A Russian economist called Kondratiev, he came up with his theory of long waves, which was taken further by Schumpeter and more recent scholars as well, which says economies move in cycles, and the single biggest thing, of course, wars and other exogenous factors have a big influence. But there's these economic cycles that have shaped the world, and you can see on the slide there the various ones of these. But the one I want to focus on is the techno-economic paradigm, which is probably the most credible theory of how technology changes society. And I'm going to unpack, but Perez and Freeman and the likes of them, they talk about these 5 techno-economic paradigms based on proper analysis of the data. So let's talk about these paradigms. But what is, we talk about this term technology revolution. And we know about the technology. What's it take to be a revolution? So it's not only the tech. It transforms labor. It transforms organizations. It transforms society. And it actually transforms international trade and locations of power. And if we go through all the previous revolutions and look at those 5 factors, and I'll make these slides available through the guys at NEC Exxon, we see that all of those criteria are met in terms of the industrial revolutions that we speak about. Now, the question is, it's one thing to say how technology is changing society. Let's look at it in the numbers. And we see that incomes have risen during this technological era. People are living longer. Poverty is falling. Infant mortality is falling. Fewer people are starving. But yes, of course, the environment is stressed. And by the way, that's not new to the era of global climate change. If you think back to the transition from hunter-gatherer to agricultural society, we changed our environment. If you think from the agrarian society through to industrial society, we changed our environment. And absolutely now we are changing our environment, and we need to be very careful. So the numbers show that it's not just some sort of conceptual thing. We actually see it in the numbers that technological change is fundamentally changing the human condition, and the way we live. And it's actually changing business as well. Some of you will have probably seen a version of this slide. If we think about the world's most valuable companies by market cap, go back 20 years, it was essentially a few petrochemical companies, a bank, a technology company, a retailer. Fast forward 5 years to 2006, pretty much the same. Still one tech company. Fast forward another 5 years, and we see pretty much the same. We start seeing the rise of China in this. We see Apple has displaced Microsoft. And then, suddenly, for 5 years forward, every single one of the world's 5 most valuable companies is a tech business. And if we fast forward to more recently, yes, Saudi Aramco came into the picture when it went public, but the rest are tech companies. And if you look at the next 5, you've still got Facebook, you have Alibaba, you have Tencent. So 7 of the world's 10 most valuable companies are tech businesses. But it's not just the tech, actually. If we look at that, Amazon, is it a tech business or is it a retailer? Is Alphabet a tech business or a media company? So it's actually the issue is what these are all is they found new ways of organizing. They're all platform businesses. So what it is it's a case of the world is changing, and it's not only the tech, it's the way we organize and the way we connect with the market that changes as well. So it's one thing to say, I've spent now 10 minutes talking about technology has changed the world. The more important question is, how does technology change the world? Because if we can figure out how it does change the world, then we can think how we can respond in a constructive, profitable way. And that then brings me to this point about the 5th techno-economic paradigm and how 5G fits into that. So Perez says that there's these 5 techno-economic paradigms. These are the common words. So from the Industrial Revolution 250 years ago to the current age of information and telecommunications. And what she notes about each of these ages is, yes, there's some technological changes that trigger it. She calls it a big bang. I don't particularly like that word. It's a trigger. But it's a whole range of new technologies that interact with each other and feed off each other and build each other. So it's these clusters of interconnected innovation, which then gives rise to new infrastructures. And now that starts pointing us a little bit. It's the first clue of where we're getting in terms of 5G. Because in each of these revolutions, these new infrastructures that arise, which drive and empower the full impact of this revolution. How do these work? I said I want to explain how it works very quickly. So what you see is level of diffusion on the vertical axis, time on the horizontal axis. And it starts with the Big Bang, or as I prefer to use the word trigger, which then leads to this eruption, a bursting in of the technology into the world, initially in a very small, confined setting in its original industry. But then it expands beyond that initial setting. And you get this frenzy of growth. And then, this is called the installation period in the TEP language, which is followed by a deployment period. And then you get the synergy where the world has learnt to appropriate this technology for social and economic benefit. And then eventually the prospect for further productivity enhancement is exhausted, and the technology reaches maturity and saturation. But you'll notice this break there, at which point you're ready for the Big Bang. You'll notice the break in the middle of this. And what's interesting is every one of these 5 techno-economic paradigms has had some bubble bursts. You get the growth, it builds a bubble, the bubble bursts. And the world reorganizes and rejigs itself to recognize that the initial exuberance during frenzy needs to be moderated and so on. And then you move into the proper synergy. But it's the choices we make in terms of how we regulate, how we socialize, how we organize and appropriate the technology that will determine the actual potential application of that technology. So that's how that's sort of the mechanics behind it. There are a few critical conditions that cause these great surges of economic development. The first is new tools, as we said. This is these new combinations of new technologies. The second, very importantly, is new organizations, new ways of organizing to appropriate the technologies and fully extract value. I showed you those platform business models. That is an example in the current paradigm about how we've learned new ways of organizing to appropriate value. And the third is new infrastructures, which actually oil and enable the techno-economic paradigm that we're in. And there are three things driving that. It's about clearly perceived and rapidly falling relative cost of these clusters of innovations. And we've seen, for example, in microelectronics, the exponential reduction in cost. We've seen it in bandwidth, the exponentially falling price per unit of data. The second, it's also about unlimited availability and a clear potential. I'm going to come back and say how that relates to 5G now. But it's these three things together, these surges of economic development, as I've said, is not just economic development. It's a very fundamental change to the nature of work and changes to the fabric of society. So that combination of new tools, new organizations, and new infrastructures truly does create revolutions that our organizations need to respond to. So let's now relate this a little bit to 5G. The fifth step that we're in, the technologies are the internet, telecommunications. I've spoken to this. The ways of organizing platforms and networks, distributed production, knowledge productionization, we've seen that. And the new infrastructures, global data networks, global supply chains, global financial networks. As we think about this current, the cyber-physical society, is it a fifth step or a sixth step? The jury is out on that. But at the moment where we are, the technologies, AI, IoT, quantum computing, blockchain, I could carry on. But what's really important is openness in the platforms and networks, distributed intelligence, not productionizing knowledge, but productionizing intelligence, codependence, and moving from a self-centered way of thinking about the world to a more socially centered way. And the new infrastructures, universal connectivity, digital identities, universal transactional networks that everybody can transact, and it's not clear what the intelligence infrastructures will be, that sort of work in progress. So now when we think about 5G, and particularly open 5G, it is a key enabler of this openness. It is a key enabler of this universal connectivity. And that is where 5G Open RAN fits into the story. Let's also look at those other things I mentioned, the three critical factors, that the clearly perceived and rapidly falling cost. We see that with, we know 5G has 10 times to 100 times more capability than what's gone before. And we're seeing hugely falling device and system costs. So that reduces the cost of the unit cost of production dramatically. We are seeing spectrum becoming available, and the coverage is really starting to increase rapidly. And the use cases offer potential for this across industries, not just the ones that it was initially contemplated. So again, we see what 5G Open RAN offers is the tools and the fundamental building blocks to make this fifth techno-economic paradigm a reality. So let me ask you a question. Who are these people and what do they have in common? Besides the fact that the demographic is disturbingly similar to this room. So what's interesting, the two on the right give it away. They are the people two of the many people who have learnt to harness what's happening in this fifth or the sixth step. The other two we know, Gordon Moore, who was a co-founder of Intel, and of course, Bill Gates. Then we see John Rockefeller and Henry Ford. John Rockefeller, oil, Henry Ford, the car, who really understood how to harness the fourth step. Then we see Andrew Carnegie, steel, and George Westinghouse, of the famous Westinghouse Industries, who learned to harness the third step. And then Cornelius Vanderbilt, who was a rail magnate and a shipping magnate. And J.P. Morgan, we think of J.P. Morgan as a financier, which he was, but he made his fortune out of the restructuring of the rail industry and factories. And then, of course, the first step, Richard Arkwright, who sort of was one of the drivers of the first industrial revolution in the UK. And Nathan Rothschild, who also was a financier, but he made his money out of investing in factories and mills. So these were people who learned to harness these various techno-economic paradigms. And what they had was the ability to get through understand this statement. Bill Gates has said, we always overestimate the change that will occur in the next 2 years and underestimate the change that will happen in the long term. Why is this? Because I think it resonates with most of us. And the reason this is we've seen how technological productivity actually develops. It happens in these S-curves. The way we think, human psychology is, in terms of our spatial psychology, it's linear. In terms of our time psychology, it's linear. So if I walk across the stage, I take 5 equal steps or something, and that's a linear process. If I was an exponential process, my first step would be small, then my next one would be quite big, and then my next one would be enormous, and then you get the picture, right? We don't think like that. And the implication of this is there's a disconnect between the way we think about the future and the way the future plays out. And that means that we tend to overestimate the change in the short term, and we tend to underestimate the change in the long term. And what this means is that those guys that I just showed you on the previous slide, they actually didn't get disheartened here. When the results they were thinking should be there, but they were actually there, they didn't get disheartened. But they saw the future. They had the vision to understand the future and translate that into business objectives and business intelligence, let's call it. So, we've seen that technology has changed the world. We've seen how techno-economic paradigm theory explains how it changes the world. Let's now quickly move into the opportunity for 5G. And to start that, I want to talk about 3 lessons from 3G, because I think it's quite instructive. Firstly, this is global mobile data usage, and we see a very classic exponential trend. But the interesting thing about this is you all rolled out your networks from around 2002 to 2005. That's when you actually deployed your networks. But there was no data usage. You can see that on the chart. Then what happened is the iPhone was launched in June 2007 in the US. And suddenly, we had a use case for 3G. And it was after we found the use case that the demand picked up. And then we saw truly exponential growth and exponential reduction in unit cost over that period. So the first is, it's only actually, in many cases, by the way, I talk about these infrastructures of the techno-economic paradigms. It is once the infrastructure is in place that people learn what the use cases are and how to harness that infrastructure for the creation of economic value. A second lesson. Let's look at coverage. So this, the blue line shows the coverage of 5G networks, of 3G networks, and of course you get the same usage. That's global coverage. And what's very clear is there's this 5-year lag between the time that usage happens. And the economists, the accountants will often say, guys, I need a payback in 42 months. I'm sorry, I don't think you're going to get it for massive infrastructures. I think 5G RAN offers opportunity for earlier monetization, but generally, the lag between infrastructure deployment and infrastructure usage takes time. And we need to just actually recognize the business case, that we need to find a business case that acknowledges that. The third lesson from 3G is, could we actually have seen this coming, this exponential growth? We built our networks here, and we see the exponential growth there. Could we have seen it coming? So the next few graphs are quite complicated, so I'm going to explain them. You see this, this is exactly the same line on a logarithmic scale. Now, the way to explain the next few charts is, at the top you see the year in which the forecast was made, you see the sources of the data, and then as I build out the thing, you'll see the solid line is the actual data traffic, and the dotted lines are the forecast, and this was the original 2003 ITU forecast. Okay, let's build this data quickly. So, in 2011, the forecast, let me start at the beginning. In 2003, the ITU said that was the forecast for 3G data. And you see it goes from about 0.15 exabytes a month to just under 1 exabyte per month. What actually happened? In 2005, we deployed the networks. We started seeing some traffic, but not much. Then in 2006, people updated their forecasts and said, actually, this is where we're heading. And each year, you'll see at the top, we updated our forecasts of what actually happened in terms of actual mobile 3G data consumption through to about now. And these were in 2019, these were the forecasts of data traffic. What can we learn from this? Is that once we were in it, our forecasts, these various dotted lines, they've been pretty accurate. But the interesting thing is, before the game, we completely underestimated, by a factor of 10 to 100 times, the level of demand that would actually materialize. And this, by the way, I would think we are about the equivalent of here, maybe here, in terms of 5G now. My sense is that we have got no idea what the actual data use will be, because before the game in the past, we completely underestimated the opportunity. So those are 3 lessons from 3G, but let's get practical. Because you guys are practical people, so what we're going to use this for? So we know you guys all know this, the anticipated use cases for 5G. Enhanced mobile broadband, ultra-reliable, low-latency communications, massive machine-to-machine type communications. My sense is we have a fairly good view of the first one. We're still figuring out what we're really going to do with ultra-reliable, low-latency comms and MMTC. It doesn't mean we haven't started figuring out, but so because it's a bit more certain, let me focus on the ones that we've got a bit of a better sight of. And to do that, let me focus firstly on this, just the mobile data. So when you look at the Ericsson mobile subscriptions forecast, this is what it looks like. Their forecast goes up to 2027. I've extrapolated that to 2030. And you might be looking at this saying, hey, Brian, that top line is almost flat. Going from 8.2 to 9.1 billion over a period of 6 years, I mean, that's like a CAGR of 4%. That's not particularly exciting. But what we really should be doing is that's the 5G subscriptions. And the business case we really should be looking at is that one. And you show that to any businessman, they'll say, that's a market I want to be in. Because what the theory shows us and practice is that growing market share in a flat market is really, really hard. 2/3 of all growth in firms comes from the growth of the sectors that they play in, not through market share growth. So you want to be playing in a sector that looks like that. So I think that's the first thing with regard to it. Now, that's essentially the traditional mobile market. Let's look at a different one. If we look at the way we're deploying fiber in South Africa, and it will be pretty much the same across the rest of Africa, is the way the fiber operators are doing it is they're prioritizing geographies. They've got the main metros, the secondary metros, et cetera, et cetera, et cetera. And they're deploying them sequentially. And you see the demographic statistics. And the sort of the middle road for forecasting fiber penetration says that by 2028, you'll see we'll have covered all of the priority 1 to 5 areas and probably about half of the priority 6 areas. How does that translate? And there's a high road and a low road, which I'm not going to go through. How does that translate into what fiber will actually cover? And you're saying, why is Brian talking about fiber in a 5G conference? So the data is here. You can see how we defined the various scenarios in terms of, because it depends on the places you cover, how much it costs you to deploy fiber, how much it costs you to install, and the CPE and the affordability that people are prepared to spend, and what your uptake is. There's all these variables, and there's high roads and low roads. But the short answer is, in the traditional markets, you have to torture the data extremely hard to get to more than 3 million homes. You know, it was a guy called Ronald Coase said, if you torture the data long enough, it will confess to anything. you can't really torture the data to get to more than 3 million homes in our traditional markets. Yes, there's the so-called mass market. And you can see there's quite a lot of additional potential there. And when you work through all this and you look at the distribution of homes in South Africa, so what you see on the horizontal axis is the density of homes per square kilometer, and you see the income on the vertical axis, and the number is the number of homes. And you'll see in these places in South Africa, that number in the black cell, 11.7 million homes in that category. And when we see the actual coverage of fiber, you don't need to see the numbers, but look at the heat map. That's where fiber will cover. Fiber will not cover where it's in black. And if we look at the percentage coverage, you'll see it's 100% in some areas, but 0% elsewhere. And the fact is, even with the most optimistic assumptions, you're not going to address the whole market with fiber. So the point is, yes, some of it will be addressed with FTTH. There might even be an opportunity for various public Wi-Fi models. Yes, there are some wireless last quarter mile solutions that can extend the fiber coverage. And yes, satellite, and particularly the new satellite constellations, might play a role. But the real issue is to connect South Africa and Africa. You cannot do it without 5G or 4G. But 5G is what provides the fiber-like experience. So to put that in numbers, yes, there's a fixed opportunity of 3 million homes, and if you go into the lower income areas, another 1.5 million, and maybe even some of the fixed wireless technologies can cover another 4, which is 8.5 million. But by then, we'll have 18 million homes. So what about the rest? So that's a really important part of the mix, and the opportunity there is enormous. Let me very quickly go over the digital divide because I'm out of time. The point of the digital divide is it's not just access. When we think about the digital divide, we tend to think, is it available and can people afford it? But there's a lot of evidence that says even once it's available and affordable, only about half of Africans use it. And even once they use it, are we actually seeing economic, social, cultural, and institutional benefits and avoiding the potential negatives? So the digital divide is actually what academics now call the 3-level digital divide. If we look at coverage in South Africa and usage, so the various short lines represent 5G, 4G, and 3G coverage in South Africa, and this red line, this one, talks to usage. So we're using it, and we're pretty well covered by 3 and 4G, so what's my story here? The point is that as good as a fiber connection? And I think we would all agree it's not quite. But most importantly, is it translating to benefit for people? Are 80% of Africans and South Africans benefiting from the internet? I don't think we can honestly say that that is the case. And we need to be concerned because we could have a virtuous cycle where digital access and usage and empowerment leads to more income, education, and employment. And that in turn feeds back to digital access. Or we could have this vicious cycle where lack of digital access and empowerment leads to more unequal education, income, and employment, and a downward spiral. And we all know in South Africa the risk of downward spirals in other areas. So we need to respond. What's to be done? I need to get through this very quickly. The point being is there's a lot of things we can do to improve access, and we have done. There's a lot of things we can and must do to improve usage. And there's a lot of things that we can and must do to translate access and usage into benefit. And the interesting thing here is 5G Open RAN enables new models. It allows a further substantial reduction of unit cost. And it can play a huge role in bridging the access divide. And then finally, in terms of the usage, it makes these new applications viable. So that can play a fundamental role in bridging this digital divide. I'm going to go through this, not going to build that slide, and I'm not going to build this slide. I think you get that. So let me finish up. I've spoken about how we've seen overwhelming evidence that technology has been a huge driver of massive social and cultural and economic change. I've said how these waves happen and how 5G is one of the technologies at the heart of it. we've seen that there's a huge opportunity, both in terms of creating wealth for ourselves, but also solving social problems. The question is, what is our response? And very simply, I showed you this picture earlier and made the point that these were the people who understood the connection from what the technology offers to appropriate new ways of organizing and adapting it and building and exploiting new infrastructures. And these were the captains of industry, and their firms became iconic and rode the world stage. I'm not saying all of our firms will be at the same level, but the same principles of seeing the future, having the vision to see the possibility, and the perseverance and the tenacity to work through that period where it's below the straight line is what these guys had. Let me finish with a different collection of 5 pale males. Who are these guys and what do they have in common? These were all guys who were at the heart of an industry that when the industry changed, they should have seen it coming. William Orton, the head of Western Union, a telegraph company, said the telephone, it's not going to make any difference. Daryl Zanuck, the co-founder of 20th Century Fox, said the television set was going to be a flash in the pan. We all know that Thomas Watson said there's maybe a market for 5 computers in the world. Another computer company founder, Ken Olsen of DC, said the PC, there's no reason anyone would want a computer in their home. Robert Metcalfe, who many of us would know, was one of the co-inventors of Ethernet. He said of the internet, it will collapse, it will go spectacularly supernova and collapse. Steve Ballmer, then at the CEO of Microsoft, said, Google, it's not a real company, it's a house of cards. 2 people who were at the forefront of the smartphone business, or the mobile phone business in the early 2000s, said, Apple, nah, it's not going to be a major competitor. We're not worried about Apple. Lou Gerstner, another IBM CEO, said, Amazon, we're doing much more in terms of commerce and e-commerce than they are. We're not worried. And my favorite, Jim Keyes, the CEO of Blockbuster, said, Netflix isn't even on our radar. Look where he is now. So the point is, these were people at the heart of an industry who should have seen this coming, but were all in a state of denial. So the question that we need to ask ourselves is, where am I in this? Are we in a state of denial about the potential for this techno-economic paradigm and our role in it? Or do we understand the opportunity? Do we understand the transformative power of this cluster of new technologies and the new infrastructures we'll create and new modes of organization to be able to grasp that and turn it into social outcomes that are beneficial, business outcomes that are beneficial, and indeed personal outcomes? So thank you very much. I'm sorry I went a little bit over time.
Thank you, Brian. Thank you, Brian, for an extremely well-researched presentation as usual. I think it sets a great base in terms of denial or vision, and I'm sure the next speaker is going to go for vision. So it's my